Okay, so for day 2 of logarithms, we're going to talk about how to graph them, and we're going to learn something about changing the base. So those are two things to mention. So part 1 would be, let me see if I can get this to scroll up or something. I don't know. All right, here we go. And so I think if you graph y equals 2 to the x, I think the first thing is, you make a table, and it's pretty fast at this point because if you raise 2 to powers, the exponent changes the output. Okay, so if you take 2 and squaring it, 4. If you take 2 to the first, you get 2. You take 2 to the 0, you get 1. And when you raise it to negative things, it doesn't make it negative. It makes it closer to 0. And the asymptote here is going to be the line y equals 0, correct? And then if you want to find the inverse of this function, you reverse the x and the y, so you get a half is going to be negative 1, 1 is 0, 2 is 1, and 4 is 2. And I think the big thing would be to plot those, okay? A half is negative 1, 1 is 0, 2 is 1, and 4 is 2. And you're going to get this function here, who is going to be symmetric to the line y equals x, because that's what happens when you get an inverse. And then also, the asymptote of this one is going to not be y equals 0, but it's going to be x equals 0. Okay, and so looking at this, and the domain and range is going to be from 0 to infinity, and then negative infinity to infinity. And that's going to be kind of the inverse of the original function. And then also, to find the inverse function, we would write x equals 2 to the y. And you're like, well, how do I solve that for y? Well, we have a new skill. It's logarithms. And they help us solve for things when they're way up high. So you would write log of 2 to the y equals x, which is f inverse of x is equal to log base 2 of x. Okay, and then I think the big thing is when we're going to graph, sometimes we'll use the property of switch like the form of what it's in, go from logarithmic to exponential. And I would only do that if it's a very simple function. I kind of want to work you towards how would you do it if you just are making a table of values, and then also teach you, hey, when the problems are really rough, can you use your calculator? And the answer is of course. And so I think the big thing is on the first one, can you make a table? And you're like, I don't know if I can. And I think the answer is that's okay, And so I think the big thing would be, if it's a pretty basic one, we'll switch forms. You could do 3 to the y equals x, and then you isolate x, okay? You have to make sure you isolate x. Okay, and so the thing is we need an order pair that makes it true. And I think the big thing would be you can pick -2, -1, 0, 1, and 2 for y and just find x, because all you need is a team. You need some points, some xy teams that make that true. And so if you take 3 to those powers, you'll get the x's that would have been, put into the argument. And so you get 1/9, you get 1/3, you get 1, you get 3, and you get 9. And so when we graph these, go 1/9 of the square to the right, go down 2. Go 1/3 of the square, I don't know where that is. Okay, 1, and then 1 is 0, 3 is 1, and 9 is 2. And so here we go. Okay, logarithms are like trees. Okay, log tree, etc. Their asymptotes are the x-axis. And so if we talk about domain and range, we would say from 0 to infinity. The range is negative infinity to infinity. And if they ask for end behavior, it would be as x goes to infinity, f of x goes to infinity. Also, as x goes to, it can't go to negative infinity, but it can get close to 0 from the positive side. Okay, and so it's kind of like limits. You can't, it won't ever get to 0, but as it approaches 0, what does your function do? Your function goes to negative infinity. So that would be the end behavior for this side of the graph. And so on the next one, you may be able to look at a table and say, okay, I can pick arguments that would be good for X, or if you're like, it's not, I don't know, that's something I want to do, it's really actually fine to say, I'm going to do 5 to the y equals I, isolate X, okay, it already is, and then just pick Y values. And be like, okay, do 5 to those powers, and you're going to get things that, honestly, if you had picked those and put them as the argument, those would be things you could actually do. 5. So if you want to kind of look at it, be like, okay, if I had put 1/5 as the argument, you would have gotten -1 as the answer. What do you mean? Well, if I had put 1/5 right here as X, 5 to what power is going to be 1/5? That would be -1. Okay, and so you might be able to see, hey, I could have picked some X's that go well with base 5, and then I could have found the answers to those logarithmic questions. And so again, you got options. And so we're looking to graph this, and we're going to get 5 is 1. And you're going to get the asymptote right here. That's what your graph will look like. So logarithms will be sprouting from the y-axis or falling from it. Okay, and the next one has a fractional base, and it's going to be falling from the x-axis or the y-axis, pardon me. And so if you're like, well, this negative thing blows my mind. Okay, it's fine. So you can switch forms and be like, okay, you can do 1/4 to the y and gives it x. That's fine. And then just plug in values for y and find x. And so 1/4 to the -2 will give us 16. 1/4 to the -1 gives us 4. 1/4 to the 0 is 1. 1/4 to the 1 is 4. Actually, I'm lying. 1/4 to the 1 is going to be 1/4. And then 1/4 squared is going to be 1/16. Remember, if you have a negative exponent, it flips it over and then brings it to the power. If you just have a positive exponent, it's just going to raise that fraction to a power. And so if you graph these, I'm going to graph it backwards. 1/16 is going to be 2, and then 1, and then 1 is going to be 0, and then 4 is -1. And you can see, it is falling from the y-axis, and the asymptote is still the y-axis here, x equals 0. So we can answer the questions as we choose to, but being able to graph this is going to be a pretty good move. The next thing that we talk about with graphing is like, okay, what if we take it up one small step here? And so on this next step, we're like, okay, I'm going to graph this log with an x plus 3 as an argument. And that makes it a smidge more difficult if you were going to just kind of grind through this and say, okay, can I pick some x's? And, it's not impossible, but it does make it up a notch. And so if you choose to switch forms, that's completely fine. You could do a half to the y equals x plus 3, but you have to isolate x. Okay, so minus this 3. Okay, so you do a half to the y, subtract 3, and you get x. So if you choose to work backwards and switch forms, you can. Okay, -2, -1, 0, 1, 2. And let's think about this. From its parent function, what does the plus 3 do to the graph? Well, it moves it left 3, and that means it moves the asymptote left 3. And I think knowing more is going to make your graph of this much more functional. Okay, it's also a fractional base, so it means it's going to be falling from that new asymptote. Okay, and so, as we do this, we could start with 0. 1/2 to the 0 is 1. And so we start with this one, it'd be 1 subtract 3. Well, that's -2. Okay, if you do 1, 1/2 to the 1 is a half. A half minus 3 is -2.5. And then you could do 2. 1/2 to the 2 is going to be 1/4. 1/4 minus 3 is going to be -2 3/4. And so easier ones are going to be negative. So if you do a half to the -1, well, that's just going to be the number 2. And 2 subtract 3 is -1. 1/2 to the -2 is going to be square it and flip it over. So that's going to be 4. 4 minus 3 is going to give us 1. So raising a fraction to the negative power is actually nicer because it gets rid of the fraction for us. So we start plotting these points. Negative, I'm going to start with the negative x values. So I'm going to start with negative 2 3/4, and I'm going to get a 2. Negative 2.5 is going to be 1. Negative 2 is 0. Negative 1 is negative 1. I'm pretty sure I'm botching these points. 1 is negative 2. And you're going to get a graph that does something like this, okay? And you can plot more points if you choose to, but we're trying to make a table to say, hey, what is going on? And notice it is the basic log base of half of x, but it's just the only transformation is going to be left 3. So the domain would be, from negative 3 to infinity, okay? Not including negative 3. And the range is going to be negative infinity up to positive infinity. And so, I think knowing kind of what transformations do, here's a transformation chart. If you put a number in front of a logarithmic word, it's going to be a vertical stretch or compression or a vertical reflection if it's negative. By the x, if you add or subtract from the x, it's going to move it left to right, the opposite of what you see. And the k, h is horizontal, k is vertical. That's going to be up or down. And remember, the up or down is going to be exactly what you see. Let's look and see if we can do this. I mean, this log here is the parent function, and the one on the right is going to be its child. What's the difference between them? Well, the one on the right is going to be moved to the left one. Okay, and so, I would suggest you practice doing this. Say, okay, can I do either by picking some values here and saying, okay, let's pick some nice arguments for this to say, okay, if it's log base 3 of 5, the numbers that I could pick would be of x. It would be 1/9, 1/3, 1, 3, and 9. And if I place any of these arguments here, okay, I can answer this to say, okay, log base 3 of 1/9 is going to be negative 2. Log base 3 of 1/3 is going to be negative 1. Log base 3 of 1 is going to be 0. And this is going to be 1, and this is going to be 2. So you can practice either changing forms, okay, or you can practice picking x's and finding their y's by taking 1, 3, 9. If it was like 5, it'd be 1/5, 1/25, 1, 5, and 25. So picking friendly arguments will be a good move, okay? And so as we graph these, you can graph just a couple points to say, hey, I get the good idea. It's going to be like this, okay? And then if it's going to be left 1, it's going to be just this left 1. And I think, what I want to show you is, yes, you can switch forms. You can go 3 to the y is equal to x plus 1. Make sure you minus 1 from both sides. You get 3 to the y minus 1 equals x. And so you can pick some y values. And you can say, okay, let's do this, by taking 3 to the power and then subtracting 1. You can also, one thing and I can show you this on the next sheet as well, but there is a way to say, if my goal is to pick, say, 1/9, 1/3, 1, 3, and 9, can I pick x's that give me that as the argument? And that becomes a little bit more tricky. And that's where you're like, well, I just set my goal to parentheses, the argument for x, and then I can figure out what x would have to be. I can show you that quickly for an example to be like, if you put 9 equals this right here, you would do 9 equals x plus 1, subtract 1 from both sides. If I pick 8, then 2 would be my answer. You would get the same answer if you did, plugged in y for 2. 3 squared is 9, 9 minus 1 is 8. And so you can see there's multiple ways to get that team of values. Some involves just picking x's that give you good arguments that you can evaluate logarithmically, and so you can set your goal for that base equal to the argument, and that will help you pick x. So in the next one on 3, you do 3 equals x plus 1. Okay, subtract 1 from both sides, you get 2. Well, you get the same answer over here if you did 3 to the 1th minus 1, and that gives you 2 as well for x. Okay, so there are multiple ways, like I said, to come up with these answers, and you can choose them, choose to either way on these basic ones that I would ask you to do without a calculator. If you plug in 0, you would get 0. If you plug in -1, I'm going to go over to the side over here. 3 to the -1 is going to be 1/3 minus 3 is going to, or minus 1, pardon me, is going to be -2/3. And so we can get a good idea of, hey, it's going to be 2, 1, 8, 2. Yeah, it's going to be this exact same logarithmic graph, but it's just going to be move left 1. Okay. And so down below here, it's like, okay, what would be the parent function? And then what would be the transformations that would have occurred given this, the child function. Okay, so the parent, just like if you had y is equal to 2 to the x, the children would be y is equal to 2 to the x plus 1 or x plus 1 minus 7, blah, blah, blah. The bases stay the same. So same with logarithmic functions. The parent of this one would be log with the same base of just plain x. And so on the second one would be f of x is equal to log base 1/3 of just plain x. Okay, so the parent-child relationship, the commonality is going to be the base, just like it is with exponential functions. Okay, so I think the question is, what happened to this? Okay, this would be, because it's in front of it, it'd be vertical compression by 1/3. And now the common ditch to fall in is like, oh, it must be right 1. Well, no, okay. The truth is, it's not in parentheses. See on number 2, and this would be left 2, okay? But this right here is outside the parentheses, so it really is down 1, okay? A lot of times people do -1 plus 1/3 log base 6 of x, just so that kids do not fall in that ditch and say, oh, it must be, no, the x minus 1 is not in the parentheses. It's not in the argument, it's just the x. So just heads up. This is going to be a vertical stretch by 4 and left 2. And then the last one is going to be a vertical compression by 1/4, right 3, and up 5. The last row I just said, hey, can we solve for x? Okay, we'll divide by 2. Okay, so x is equal to y over 2. How do you solve for x here? You square root both sides. So x is equal to plus or minus the square root of y. And this one, how do you solve for x? Logarithms. So it would be log 2 to the x equals y. Okay, so that would be how you solve for x here. Okay, so the last thing we did, and let me see if I can navigate this cutely. I don't know if I can. I have to zoom out a second. I'm going to pause. Okay, so on this section, okay, I just want to focus on just a little of this, like at the bottom, basically. I think I am going to hijack this graph paper here and say, okay, if you would, do like, not this, but if you would graph y is equal to log base 7 of x, do you know how you'd make a table? Do you know that you would just pick 1/7? Okay, so yes, you'd pick 1/7. Let's pick 1/49 first, and then 1/7, and then 1, and then 7, and then 49 for x. And then you can place those in the argument column and say, okay, 7 to what power is going to be 1/49? Okay, that's -2. 7 to what power gives you 1/7? That's going to be -1. 7 to what power is going to give you 1? That would be 0. And then 1, and then 7. And so you can get this graph by picking strategic x values, okay? And then I guess my next question would be, when you move up to larger functions, can you also do those values by saying, okay, this right here is going to be the parent function log base 5 of x, but it's going to be reflected vertically, and it's going to be moved up 4. Can we pick some values that are not terrible to help us find these answers? And so But because it's base 5, we would use 1 over 25. Like these are more complex, and I would not suggest switching forms for them. I would not. Okay, so I'd do 1/5. I would do 1. I would do 5, and I'd do 25. So if I'm picking values, those are values that I would pick to help you find those answers. So you place those values as the argument, and then you evaluate the function. So if you pick 1/25th, you would do 1/25th right here. And you say 5 to what power is 1/25th? That's -2. And then you bring down the negative, so it's minus a negative. So 4 minus a negative is going to be 6. Okay, so that's your first thing. 1/25th is going to be 6. So 1, 2, 3, 4, 5, 6. Okay, and then 1/5. Okay, if you put a fifth here, you're going to get -1 here. And so you do 4 minus, that is going to give us 5. Okay, so these are hard to graph, but we're going to go with it. Okay, so then if we want to place right here as x, the 0, okay, then we're going to, oh, not the 0, but the 1. So if we put x is 1, so 5 to the what is 1, that's going to be 0. So this answer will be 4, which makes sense. It's getting smaller and smaller. And then if you put a 5 as the input, let's see. We're going to put a 5 here. That'll be a 1. So 4 minus 1 gives us 3. And you're getting the general idea, you know. And so 1 is 4. 5 is 3. 1, 2, 3, 4, 5. 1, 2, 3. And you're going to get a graph with an asymptote on the y-axis. The domain is from 0 to infinity. The range is from -infinity to +infinity. You can do this question. Now, when you look at the next question, you know, it's a little harder. And I think that's where you have to say, okay, what are my goals? You know, my goals for base, let's see what this is. Base 3 are going to be 1/3, 1/9, 1, 3, and 9. However, the problem is that, you know, the argument is not just plain x. So we have to adjust our x's based on our goals. So if our goals are going to be those nice things that you can evaluate, 1/9, 1/3, 1, 3, and 9, you're going to set your argument equal to your goal and then solve for what x should be to plug it in to get y. So these are harder to do, but they're, I mean, like we can start with like an easy one. Let's start with 1. Okay, if our goal is 1, we'll set your argument equal to 1. So 1 equals x minus 2, and you can add 2 to both sides. So that means that our x should be 3. So if we plug in x as 3, our argument will become 1. What do you mean? We'll plug in x as 3. 3 minus 2 is 1. Okay, so then we're going to end up doing 2 times log base 3 of 1, and then we're going to add 3. So if you have to evaluate the logarithm, 3 to what power is 1? That's a 0. Then times it by 2, and then add 3. So your answer will be 3. Okay, so you have to choose x's to get your argument to be cute, because if you're trying to do logarithms, you don't want to pick the most obnoxious arguments. Okay, so pick x's so your argument will be adorable. Okay, so set your argument equal to your goal to figure out what x should be. Okay, so if you've got you want your argument to be, say, 3, well, then set your argument, which is x minus 3, the parenthesis, equal to 3. Add 2 to both sides, you get x is 5. So if I plug in x is 5 to my function, 5 minus 2 gives us 3. And if I evaluate the log base 3 of 3, I get 1. Times it by 2, okay, you get 2, and add 3, you're going to get 5. Okay, now they don't always match, but we could try 9. Okay, if you try 9, set 9 equal to your argument, you're going to get x is 11. And so if you plug in x is 11, 11 minus 2 is 9. 3 to what power is 9? That'd be a 2. 2 times 2 is 4 plus 3 is going to give us 7. Now, when you have fractions, it's a little bit trickier. Okay, so if you set your argument equal to this 1/3, you got to add 2, so there'll be 2 1/3. So if you plug in 2 1/3, and you say 2 1/3 minus 2, you get 1/3 here as your argument. 3 to what power is 1/3? That's a -1. I should erase this because it's rather ugly. So again, pick your x's based on making nice arguments. Okay, so if you put in 2 1/3 and minus 2, you get 1/3. 3 to what power is 1/3? That's -1. And if you do 2 times it, you get -2 plus 3. It's going to give us 1. So we're getting, we're picking x strategically to help us find the nicest values, to make this graph. Another thing that I taught my classes was you can go to the y equals screen and you can type in a 2, because there's a 2 for a coefficient. And then if you hit math, alpha math, you will get a log with a base option, okay, where you can type in what you want, math, alpha math. And then you can type this in and look at the table. And you'll notice when you look at the table that there's an error for certain things. Yeah, because the truth is you can't take a log of negative arguments. And so picking x values when your x values are too small, well, then they don't make sense. The logarithm, even a calculator, can evaluate what those are. And you can look at the table and find some good values and say, okay, this is going to be the parent graph, move to the right 2. It's going to be up 3, and it's going to be a vertical stretch by 2. And so, when you go to graph 2 1/3 and you get 1, and you go to 3 and you graph 3, and you go to 5, and you graph 5, okay, and you're going to get this graph that you expect. However, it's just sometimes a little bit more tricky than you want to do. So math alpha math will help you. Now you're going to have some problems where you have to do it without a calc. Those ones that we've done without a calculator above and on the previous sheet. But also evaluate a lot of logarithmic problems. But I want you guys to be able to say, I can figure out these answers. If you read this problem here, it says, how much time would it take for you to have 2,048 amoebas? Well, to evaluate this, we can put this in our calc, use math alpha math, and that will help you figure out what it is. You can switch forms as well, say, well, can I figure this out? But math alpha math will help you evaluate the right-hand side, and you can get the answer. The next thing is, when I ask you to not use a calc on a question like this one here, if I look at 15, I'm like, I don't know, what the answer 4 to what power is 128. That's kind of hurts my heart. It's not a pretty basic situation. And so same with the next one, I'm like, okay, do you hate children? Okay, well, there's something that is really helpful. It's called the change of base. And when you feel like your teacher is trying to destroy your heart by asking you questions that they don't seem very natural, 4 does nothing makes, it's going to be a fraction. How do you come up with it? And you slice it diagonally downhill. And what you do, go downhill to make it easier. And so you do the log of the big number, or the argument, okay? Not numerically bigger, but the argument, okay, over the log of the base, okay? So this goes on top, this one goes on the bottom. And then you choose a common base that you think would be helpful, because it'll be proportional. Every number you pick will be the same answer because it's proportional, but pick something you could do without a calculator, okay? And so in this case, it's going to be log base 2 of 128 over log base 2 of 4, okay? And you have to say, okay, what would that be? Okay, 2 times 2, 8, 16, 32, 64, 1. So it'd be 7, okay, over 2. If you check this, okay, and try, does 4 to the 7 halves give you 128? The answer is yes. How do you know? Well, you just take the square root of 4 and then raise it to the 7th power. You do get 128. So anytime, like on your homework, that worksheet, I want you to do the top half of it without using a calculator. And so when I ask you crumbly questions, you're like, oh my heavens, you always put the argument on the numerator. So you would do log of 243 over the log of 127th. And you're like, pick a base that seems cute. Okay, 3 seems great. Okay, 3 to the negative 3 is going to bottom. Okay, 3 to what is 243? I believe that's 5. Okay, and I'm going to check that on my calculator. Be like, okay, what is 3 to the 5th? It is 243. Okay, and so yeah, if you raise 127th to the negative 5/3, do you get 243? Okay, we're checking it. So the answer is your argument, or is not your argument, it is the exponent answer that you get, the negative 5/3. And so you'll use this on that, the top section of the second section of your homework on the front when I ask you to say, hey, evaluate these. Don't use a calculator. Okay. All right. Well, thank you. Have a good day.